Okay, so this is week 13, experiment 121, and we were planning on using our modeling clay, but that got dried out and it's going to be kind of a pain to make it into a ball. So instead I have this northern hemisphere, southern hemisphere styrofoam ball with a stick stuck to it. So we can share this and this will be easier than the clay. So this is our Earth, right? And so you can talk about the axis and northern hemisphere, southern hemisphere. And this is our sun, represented by our flashlight. So you want to turn off the lights and make it a little bit darker. And it says to hold it 6 inches apart, maybe like that. And oh, okay, apparently this is called the axial tilt. Having some help explaining this. So this is the axial tilt. And so we're going to start like this. You can see the southern hemisphere. Where is the sun hitting the Earth, right? It's hitting it more on the southern hemisphere. So that means it's winter here, but summer there because it's getting the hottest part. So then we're going to have it travel around the sun, representing the seasons. And you'll have to obviously have them kind of gather around to see where the flashlight's hitting. But now my flashlight is more on the northern hemisphere than it is on the southern hemisphere. So this is summer. So this is the conversation you're having, basically, observing where the sun hits it. The main point of this whole thing is to talk about the tilt of the Earth and its effect on seasons. That's it.
Okay, so this is week 13, experiment number 127, and Peter is going to demonstrate for us what we're going to do. So first step is to fill the jar half full of water, which we did, and then we are going to add our cup of soil somehow so we don't spill. Whoops. Okay, that might happen, so we're going to be careful with that. Can we get it in there? Maybe put something down under your workspace. That might help. This is more of a demonstration, but obviously let the kids be involved. And then we're going to put the paper clips in. That's okay, don't worry about the rest of it. Oh. Yep, so we're going to put the paper clips in. So 5 paper clips. And then we're going to put the cover on tightly. Oh, nice and tight. Good. Then we're going to shake it. Are you sure it's on? Do I need to check? Let me just check. Put it down a sec.
Okay, yeah, good.
Shake it, shake it, shake it, shake it. So in your classes, you can probably have different students shake vigorously. So we're going to keep shaking. And then we're going to set the jar down. Is it shaken?
Yeah.
Okay. So we're going to let the jar sit for 5 minutes and then we'll come back. So we're back with our experiment. We let it sit for 5 minutes and now we're going to observe it. So Peter, what do you see?
On the bottom, I see the
Oh,
paper
don't
clips.
turn it. Keep it upright. Can you lift it up and look at it? Look at the bottom. What's down there?
Paper clips.
The paper clips. Okay. So they settled to the bottom. It's a little hard to tell. Can you put it down? It's a little hard to tell, so I'm thinking maybe use less soil than a full cup. Maybe a little bit less. And so the conversation is about what happens when just rain comes or there's, the soil gets moved around. What happens to the heavier materials that sink down? So it's talking about metal in particular. This is called placer ore. So lots to discuss there. We're observing and attending. Okay, so this is week 14, number 126, sampler, and Ben is going to demonstrate for us. We're talking about core sampling. Basically, how do scientists know what's in the earth? How do they know about rock layers? How do they know what's going on? So to demonstrate this, we are going to use clay. We have 3 different colors. So you can see, we have 3 different colors of clay. And we have flattened them and stacked them on top of each other. So we have a block of clay, and then we have a straw, and we're going to push the straw through the layers of the clay. And it's a little bit hard, which is why I got these milkshake straws. You might have to twist it. Twist it without squeezing it. So this is a demonstration, which means, you know, not every student gets their own blob or anything. They're going to have to work together. Oh, try not to pull it out. Try to keep it in there. And then when you get to the table, is all the way through? You have to twist it a little.
Yeah, it is.
Is it through?
Yeah.
Okay, now pull it out. Good. And then he's going to take the scissors. You take the scissors. And he's just going to cut right along the line of the straw so we can peel it back. Oh, careful. So you can peel it back and get the piece out gently so it's in the same. So there. So now we can see what was inside. So when we were looking at, this is upside down. When we were first looking at our clay, all we could see if we were above ground would be the red part. But when we dig down there and get a core sample, we can see the different layers. There we go. Thank you. So this is 128 prints. We made a golf ball sized ball of clay, and we coated the shell in Vaseline. Yeah, see, we coated it, and then we pressed it in. And then we mixed our plaster of Paris in a cup with, what do we do? 4 teaspoons plaster of Paris and 2 teaspoons of water. And now we're gonna try before I get in there. Okay. And then we'll just let it,
That might have been too.
yeah, it might have been too much, but we'll find out. We're just gonna let it dry for 15 to 20 minutes. So after it dried for a long time, like 30 minutes, no, closer to an hour actually, you can lift it out and see it. So we probably put too much plaster of Paris in it, kind of overflowed on the edges. You can put a little bit less, but it should, the fossil should pop right out. I guess to go like that. And then you can throw this away. And remember to throw plaster of Paris away. Don't ever pour it down the drain because it'll clog it up. But you can just throw, if there's any extra from what you mixed up, you can throw it away. This is week 16, experiment number 130, stretch. And the point of this is to talk about tension force as it relates to rocks. So what you need is a balloon and a Sharpie, and we'll do it in pairs. You'll have to make sure each pair has someone who can blow up a balloon. And then you draw the 3 sections. Sam, can you show what's drawn on there? So you draw like a rectangle, and then you divide it. So now you have, you know, the 2 dark sections around the outside and blank in the middle. And then you're gonna blow it up.
I'm gonna watch what happens when we blow it up. There we go. That's good. And so they can both just hold it and discuss what happened, why did it happen, what would happen if you kept blowing, like you kept blowing and blowing and blowing and blowing and blowing. I don't know if I want you to do that. Just a hypothetical question. What would happen? And then as it relates to rocks, that some rocks are able just to kind of bounce back when that tension is lets up, but some rocks get pushed so far and maybe they're not as able to stretch a little bit, and then you have an earthquake. So this is for week 16, experiment 132, spurt. So all you need for this is a half empty tube of toothpaste, and the tube of toothpaste I gave my tutors is, they're full, so you'll have to use some toothpaste or at least squirt some out before class, before we do the experiment. So the conversation is about magma, which is liquid rock, and how does it move. And so what you're going to do is just hold it, and the cap's on. You don't want the cap, you want the cap screwed on really tight, and then just move it around. So this is something each of the kids can take a turn doing and discussing. Why is it moving? Is it moving on its own, or is it because there's pressure being put on it? And what happens if, if you squish it one spot, you squish it in one place. If you squish it in one place, where does it go? And it goes to the other place. And if you squish it somewhere else, and so the conversation is about just the magma moving. It can move horizontally, it can move up, and it's always there, right? There's always magma in the rock layers below. So you can have a dialectic conversation about that. There you go.
Okay, this is week 17, rock bridge, and we're talking about how do natural bridges stand? How come there's a bridge there? It's just rocks. So Ben and Peter are going to demonstrate for us. We have two chairs about a foot apart, and we're going to go, each of them are going to go from a side, and they're going to try to just go slowly, a little bit at a time, to see if, whoa, there's a big book. Does that work, Peter? Might need to stick with smaller books. That was a good test to see. Oh, there you go. See, we got to go little by little. Otherwise, they tip over. So this will be a fun activity. The kids will have to work together. Maybe it could be more about, maybe it could be more, like I just told you how to do it, but maybe it could be a lot more discussion about how do we do it and what happens if we do what Ben's doing right now. Is that going to hold? Figured out a way to do it, I guess, but I don't think that's how rocks form. Don't they form one layer at a time, kind of orderly? So anyhow, this is how you conduct the experiment, and then you can try it different ways, different times, different positioning, and have dialectic discussion. Okay, so this is week 18, experiment number 140, push-up, and it's talking about atmospheric pressure. So, can just discuss the air outside of us is pushing down on us at all times, all the way down from the atmosphere, and this is going to demonstrate that. So, we're going to take we have two things, just a glass bowl with the water filled up 3/4 of the way, and then the bowl doesn't have to be glass. I know yours is plastic. So the clear bowl, and then a drinking glass, which that has to be glass. And then we're going to put it in the water, and we're going to scoop up as much as we can, and then really quickly we're going to tip it down like that. So now we have water underneath here. And so we're going to
slowly lift the glass up just about an inch. And I don't know if you can see in here, but the water level now in the glass is higher than the water level in the bowl. And that is because of atmospheric pressure. So the water is staying higher because it no longer has as much atmospheric pressure pushing down on it. Yeah, so there you go. Probably you can just do it repeatedly. You can let different kids give it a try. See if make sure you can see it. It's really hard to see because it is water and it is clear. So there we go.
Okay, so this is week 18, experiment number 142, updraft. And what we did is we cut a 2-inch spiral out of the tissue paper and attached a thread with tape, and the thread is 6 inches long. So you can measure that and do it in class. I just did it now to speed things along. So, and then we have our desk lamp. So we're going to turn that on. We're going to hold it above it. Make sure you don't get too close, and we're going to watch what happens to the tissue paper ring. So it's just hanging out for now. It's moving a little bit. So this has to do with energy from the light. So the energy from the light is going to heat it, and then the air molecules are going to move faster and faster, and they're going to be lighter, right? Hot, warm air rises, and then the cooler air is going to come in and take the place. And so the result of it is going to be
there we
a
go.
current. Is it going now?
I had to make it higher up.
Oh, that's interesting. If you're too close, it doesn't work as well, maybe.
Trying to find the right spot.
Well, and part of it might be the way I taped it. So that's something to be aware of. How it's taped can affect it too. I don't know if you can see. Can you turn the thread just a little bit now? Just in your hand. I was doing it before. There we go. There we go. Sort of. I think I might have used too much tape as part of it. But it is moving at any rate. Like if you took it away from the lamp, it would hold. No, don't do it. No, you can. Sorry. Take it away from the lamp. Does it do anything? No, it just stays there. Okay, now come back to the lamp and let's see what happens. There we go. There we go. Now it's moving. So
I think it took a second
this
for
is-
it to warm up.
it took a second. Oh, for the bulb to warm up. That's a good point. So this is a lesson in air current. Just have discussions based on that, asking your 5 common topic questions. And there you go. So this is week 16, Durer. And so what you need is your pink foam, and I have white tablecloths for you to put, white plastic tablecloths to put down so you don't get ink everywhere. And then you're going to take your tool, your stylus, and you're going to draw what, you know, the kids are going to draw whatever they want. Obviously, first of all, explain what you're doing with this engraving. But as far as the procedure goes, they can make different designs, they can make it like something real, like Durer did with the rhinoceros, or you know, just a pattern or something. Okay, so once you're done with that, you're going to take your ink and brayer, which is the little roller, and you're going to roll it on there. And probably not too thick, because if it's too thick, you'll fill in the cracks where the you know, where the engraving is. So enough so it's on top, but not too much. And then you take your paper, you're going to make your print. Probably have to do this for the kids, or at least supervise each one for the younger ones. And then lift it up. peel it off maybe. And there you go, all done. You'll probably have to dry them up on the little clothesline thing with the clothespins. There you go. So this is the Michelangelo fresco plaque, and we're not going to use Christmas plates. I'm just trying to figure out the right size. So we mixed, what did we mix?
Half cup of plaster
Half
Paris.
cup of plaster of Paris with a quarter cup of water. And now we're going to see if it's the right size. Well, that fits. And now we're going to let it set. Oh, first we have to do our paper clip right here. Oh, she has one. So I can't see what you're doing. Yeah, so you just bent it out just a little bit, and then we're sticking it in there. So hopefully when it sets up a little bit, you'll have a built-in hook. So it says to set it up briefly. So look back. Okay, so it's been, what, 18 to 20 minutes? Okay, we're gonna see what happens when we try to take it off. Ooh, does that look nice? I think it does. And here's the Michelangelo fresco. While it's still damp, you can paint on it. They'll use tempera paints and paint whatever design you want. If you want them to have something in particular, you can do that, but Peter did a flag, so there you go.